Imagine standing at the edge of a massive golden ocean. The surface shimmers and moves, giving off loads of heat and light. This is the sun, the center of our solar system, a giant ball of burning gas that keeps our planet and all the others spinning around it. The sun isn't just any star, it's star, the reason there's life on Earth. It keeps us warm, powers our weather, and gives energy to everything that lives. But what if we could do more than just look at this giant star from far away? What if we could travel to the sun and feel its power up close? Of course we can't do that with the technology we have now. The sun is like a giant furnace. Its surface a scorching 5,500 degrees Celsius, hot enough to instantly vaporize any spaceship we could build. But let's pretend for a bit. Let's imagine we have a special ship that can handle the sun's crazy heat and radiation. What would we see, hear, and feel as we flew into the heart of our star? Our journey starts in the darkness of space, far from the sun's bright light. As we get closer, the sun gets bigger and bigger, its light getting stronger. We pass Mercury, then Venus, feeling the heat rise with every second. Soon, the sun fills our view, a huge ball of glowing plasma, its surface a messy mix of swirling gas and magnetic fields. We're now entering the sun's atmosphere, a place of intense activity and unbelievable temperatures. Our imaginary spaceship would need to be made of stuff that doesn't even exist yet, able to handle conditions that would melt anything we know. But for our imaginary trip, let's just say such a ship exists. Our trip through the sun's atmosphere starts with the corona, the outer layer. You can see the corona during a solar eclipse as a pearly white ring around the dark sun. Even though it looks delicate, the corona is incredibly hot, reaching millions of degrees Celsius. This extreme heat is a puzzle that scientists are still trying to solve. We know the corona is made of very thin plasma, so even though it's super hot, the heat wouldn't feel as strong as you might think. Next, we dive into the chromosphere, a thin layer between the corona and the photosphere. Here, temperatures range from thousands to tens of thousands of degrees Celsius. The chromosphere is a busy place, home to solar flares, which are sudden bursts of energy, and prominences, which are giant loops of plasma shooting out from the sun. Finally, we reach the photosphere, the sun's surface, the bit we see from Earth. This is where the sun's energy, made deep inside its core, finally escapes into space. The photosphere is a rough sea of gas, with temperatures around 5,500 degrees Celsius. Here we see the sun's famous sunspots, cooler areas caused by strong magnetic activity. As we go deeper, we leave the familiar light of the photosphere and enter a world of constant darkness. The sun's inside is opaque, its massive pressure trapping light within. We're now falling into the sun's interior, pulled in by its huge gravity. The sun's gravity is 28 times stronger than Earth's, meaning a person weighing 150 pounds on Earth would weigh over 2 tons on the sun. As we fall deeper, the temperature and pressure keep rising. We're now in the convective zone, a place where heat moves through the movement of plasma. Giant convection cells, thousands of kilometers across, churn the sun's inside, carrying heat from deep down to the surface. The trip through the convective zone would be a bumpy ride. We'd be thrown around by the churning plasma, hit by intense radiation, and squashed by the ever-increasing pressure. But our imaginary spaceship, unaffected by the sun's fury, keeps going down. Section 4. The sun's core, where energy is born. Our journey ends in the sun's core, the very heart of our star. Here, temperatures reach a mind-blowing 15 million degrees Celsius, and the pressure is billions of times stronger than on Earth. It's in this extreme environment that the sun's energy is made through nuclear fusion. Nuclear fusion is when tiny bits of atoms join together to make bigger atoms and other tiny particles, like neutrons or protons. The difference in mass between what you start with and what you end up with creates a huge amount of energy. In the sun's core, hydrogen atoms under massive pressure and temperature are squashed together to make helium, releasing loads of energy. This energy, in the form of gamma rays, then starts a long and difficult journey outwards, eventually reaching the sun's surface and shining out into space. Section 5. Unraveling the sun's mysteries: scientific missions. Our imaginary trip into the sun is still just a dream, but scientists are always working to understand our nearest star. Spacecraft like the Solar Orbiter and the Parker Solar Probe are giving us amazing new views of the Sun's atmosphere, magnetic field, and solar wind. The Solar Orbiter, a project between the European Space Agency and NASA, is designed to study the Sun's poles, giving us a special view of our star. Meanwhile, the Parker Solar Probe is on a daring mission to touch the Sun, flying closer than any spacecraft before. These missions, along with others like SOHO, which has been watching the Sun for over 20 years, are giving us tons of information that's helping us to better understand the Sun and how it affects our planet. Section 6. The Sun's enduring influence. Our pretend journey into the Sun might be over, but the Sun's real journey and its impact on our planet goes on. The Sun is a powerful force, shaping our world in so many ways. It gives us the light and heat we need for life, controls our weather, and even affects our climate. As we continue to study the Sun, we understand its power and complexity better. We learn more about what's inside it, its magnetic field, and how it makes its energy. And with every new thing we learn, we get closer to understanding the special relationship between our star and our planet.